Okay, so our next unit's on vectors. We're going to start with vectors, but before we get to looking at vector questions and doing some trigonometry and solving for angles and missing sides and stuff like that, we have to be clear on how our direction system works for physics. So the first thing that you got to be careful of is when you see something with a direction, you have to be able to locate where that exactly would be. So most of the questions we're going to get for this unit is you're going to get some sort of vector, so it could be a displacement or a speed or whatever. So let's just suppose it was 10 meters per second, and then they're going to tell you that's going to go at some sort of angle. So let's suppose it was at 30 degrees. What we're going to want to do is be able to break that vector into horizontal and vertical components. Then we could basically solve the questions a lot easier. So that's going to be our main strategy. So we're going to be getting into the trigonometry and stuff later on. So basically, as hard as the trig's ever going to get is you would get sine 30 would equal, in this case, the red, let's call it x. We'd have, or let's call it y, doesn't matter which one's which. So let's, for now, just keep it sort of simple. Let's call that our y direction. So we'd have y divided by 10. And then on the bottom, we'd have cosine of 30 equals adjacent over hypotenuse, so x over 10. So that's about as complicated as the trigonometry is going to get for this stuff, which is good. Everybody's done this before. But the hard part is locating that direction. They're not going to give you the triangles. Usually it's going to be in words, so you have to be able to draw the triangles and figure out the directions on your own. So the first topic that we're going to look at, or the first way of doing directions, is based on the Cartesian system, which is what we use in math. So those of you doing math 20-1, you would have done this already in the trigonometry unit. So what we do with the math directions is we always start at the 0 degrees over on the right side, then we go up to 90 degrees on the top, 180, and 270. So in physics, if the question was you're going to go 10 meters at 70 degrees, then what we would do is that means we're going to be drawing this thing from the 0, we measure 70 degrees upwards. So that would be where our vector would be. And then from there we could figure out our vertical and horizontal components if we need to. So that's the first one, 10 meters at 70 degrees. And for today, we're not going to worry about the 10 meters. I just want to worry about where the location would be. So the next one is, let's suppose I told you we have something located at 220 degrees. So the 220 would be, we'd go around to the 180, and then we'd add on a little bit more, and that would get us to 220. So the 220 degrees would look something like that. And then later on, when we do the trig calculations, we're not going to worry about the 220. We're going to basically make our triangle out of that, and then we'd use 220 minus 80. We'd use 40 degrees inside our triangle. Okay, so let's do a couple more. So where would 350 degrees be located? Well, that's going to be all the way around, just not quite to the 360, which would be the 0 location, so that would be about 10 degrees like that, or 350 all the way around. Okay, so in math terms, we call those the reference angles. So where 350 degrees goes all the way around, our reference angle would be the 10 degrees that we're going to work with. And let's do one more. Let's suppose we had an angle of 140. That's going to be something like that. So our reference angle in this case would be 40 degrees down there. Okay, so those of you that are doing this in math, this will seem familiar. Okay, so you'll find this system pretty basic and pretty easy. You just have to make sure you always go from the 0 and measure your way around. The next system we're going to look at is probably, I don't know if it's used more than the other one, but it's used quite a bit in physics. And this is the navigation one, and in this case, this is like a GPS system where we use north, east, south, and west instead of the math system. So in this case, you're going to get questions where they'll say things like, we have a vector going at north 30 degrees east. Okay, so what you have to do is you have to be able to figure, okay, what is that? Where's that location? So in this sense, the first letter is telling you we're going towards the north first, and then we're going to be moving 30 degrees from there towards the east. So in terms of drawing our triangle, it would look something like that, where our 30 degrees would be down there. So from the north towards the east, that would be where our angle would be. Okay, so let's do a couple more of those. So if I gave you south 65 degrees west, that means we're going to be moving from the south towards the west, and we're going to go 65 degrees. So it would look something like that. Alright, if I gave you, let's do one more, let's do east 20 degrees south. So just similarly, we'd be heading towards the east first. So from the east towards the south, we're going to go 20 degrees. Okay, so that's sort of the navigation system. And they work pretty good. If you get a question that just says northeast only, then that means it's perfectly right down the middle, so that would be 45 degrees northeast or 45 degrees east of north. So if you get two angles, so let me just write that one. So if I go north 45 east or east 45 north, because they're both 45 degrees, those are exactly the same thing. So there's no difference in either way. That's why we can just write it as northeast, and it doesn't make any difference. But if I gave you, let's do a different one. If I gave you north 30 degrees west, and I gave you west 30 degrees north, those are not the same. Okay, those aren't the same, because north 30 degrees west would be from the north towards the west 30 degrees, and west 30 degrees north would be down here. It would be 30 degrees upwards from the west. So those aren't the same, but what you could do if you get one and you need to figure out the other is, instead of being north 30 degrees west and west 30 degrees north, all you'd have to do is change the other one to the complementary angle. So if this angle up here is 30, that means the one below it would be 60. So north 30 degrees west and west 60 degrees north, those are the same. Okay, and it wouldn't matter on a test if you're writing them, either one would be acceptable. There's one other thing we got to look at when we're dealing with these. I'll just start a new page. So if we get a direction system like that in the textbook and in other older materials, quite often they'll write the angles, instead of the way we just wrote them, they'll write them as 40 degrees north of west. So in this case, it says 40 degrees north of west, we're going from the west towards the north, north of west. So in this case, that 40 degrees north of west would be like that. And if you use the one that we just looked at, we said we're heading west, then going 40 degrees north. So that would be, those two things are the same. So some people get mixed up with this north of west, south of east. So if you ever do that, if I gave you a question that was 35 degrees south of east, if you want, you can switch it to the other way around, move the east to the front, so you'd have east 35 south, and those two things would be the same. So east 35 south would be from the east towards the south, 35 degrees, or if you can understand 35 degrees south of east, that's the same. So either one, both of those systems are good. You're going to see questions where they're all mixed up, so you just have to be able to sort of draw any kind of scenario. So if I gave you a different one that I said 60 degrees west of north, or I told you to draw west 30 degrees north, or I tell you to draw 120 in the math Cartesian system, you should see that these are all the same thing. So 60 degrees west of north would be 60 degrees west of north would be like that, right? From the north, we're going 60 degrees towards the west. Or the other one, west 30 degrees north. So from the west, we're going to head 30 degrees to the north, would be there. And I messed up on the last one. It shouldn't be 120. It should have been 150. So if we measure in the math system, 150 degrees would go all the way around and we'd get to there. So all three of those are the same. It doesn't matter which one you'd be given. you're going to see that they're all exactly the same location. So any particular question could use any of the three locations.